Hello, everyone, and welcome to the ICOVISIONS podcast. My name is Jam Crypto. I'm your host, and today we have a very special guest by the name of Paul Madsen. Did I pronounce your name correctly, Paul?
I think you did, Jam.
Great. And he is actually coming from Hedera Hashgraph and Swirlds.
Yeah, and we can explain the sort of the relationship between those three things.
Fantastic. So I guess just to start now, who is Paul Madsen and what exactly is Hedera Hashgraph?
So in no particular order, I am a technical lead at Swirlds. Swirlds is a US-based software company that is bringing to the market, both permissioned and public, a consensus algorithm called Hashgraph. And Swirlds is the company that will sell Hashgraph into enterprises for their permission deployments, supply chain, healthcare, etc. And mostly separately, at least initially, is the launch of a public ledger, open public consensus based on Hashgraph that we are calling Hadera. So Hashgraph is the underlying technology, a consensus algorithm and ledger. Hadera is the public side of that, and Swirlds is the more permissioned private network deployment side of Hashgraph.
Great. Thanks for that understanding and insight as to what Hedera, Hashgraph, and Swirlds are in the three different parts.
Yeah.
Great. And I guess now, what is the problem that Hashgraph is solving and how? Maybe you can shed some light on that.
Well, I guess there's sort of two problems, one high level, one lower level. The first is that which all distributed consensus algorithms want to mitigate, and that's just the risk and associated business challenges of two parties who want to do business with each other, who may not know each other or want to have to trust each other. How do we allow them to engage in transactions, meaningful business, without having to rely on some central third party mediating that relationship and that trust? So that's the first business challenge. We're trying to intermediate trusted third parties and allow companies and enterprises and people who just want to spend money to do so without relying on somebody else keeping track of the ledger, keeping track of records and all the various metadata. So that's kind of the fundamental challenge of all distributed consensus algorithms or ledgers. Now, right. The first generation of technologies that emerged to solve that trust challenge or that trusted third party challenge, technologies like Bitcoin, Ethereum, other public ledgers, as revolutionary as they have been, and as important to as a first step towards addressing the problem of central mediated trust. They're first generation technologies, so perhaps it's not too surprising that they are confronting challenges in scale, certain security characteristics,
right.
And ultimately adoption amongst the mainstream and enterprises at least. So what we think we have with Hashgraph is just, quote unquote, a new and improved version of a consensus algorithm that we think can help address the use cases that first generation ledgers were designed to address, cryptocurrency, smart contract platforms, et cetera, but do so at greater scale, faster performance, greater security in some sense relative to public blockchains, and critically do so in the governance model that will hopefully give to enterprises and mainstream public a confidence in the stability of those platforms that we don't see currently.
Great. And I guess now, who came up with the idea for Hashgraph, or the actual,
Yeah.
protocol or consensus algorithm, and how long have you been testing or working on it?
Well, so Swirlds' co-founder and CTO is a gentleman named Lehman Baird, a colleague and friend of mine. Lehman is one of those people that gets a problem in his head, whether computer science or mathematical, and he just mulls on it and he ponders. And it took him, by his account, years of intermittent thinking about the problem of distributed consensus. But in the end, he came up with this new way to do distributed consensus. As I said, one that we think has advantages relative to other models like blockchain. So a couple of years to sort of formulate the idea. It's been a couple of years since he did so and started Swirlds with our CEO, Mance Harmon. But in the interim, they've been growing Swirlds, developing an SDK that implements the algorithm that we're seeing already adopted in the permission space. Customers are, as I said, buying that software and the associated license and building real deployments, or rolling those out at least. So yeah, far more than a white paper, working code, running the algorithm. And our next challenge is to deploy that algorithm to a public ledger. And as I said, that's Hadera. That's kind of the next evolutionary phase in how we bring Hashgraph to the market.
Great. And I guess now, did you want to happen to explain any other benefits of using Hashgraph, maybe versus blockchain?
Sure. I think people are well aware of the scaling challenges that current public blockchains like Bitcoin or Ethereum are addressing or confronting. Just performance numbers far less than Visa is the typical measuring stick against which public ledgers are compared. And Visa does, it's either 5,000 transactions per second on average, or maybe peaking to 50. I've seen different numbers. Clearly, Bitcoin and Ethereum don't do that, and they know they don't do that, right? And they have, as they should, a roadmap by which they can scale up over the years. Depending on how we deploy it, depending on where the nodes are distributed, how many nodes, depending on the sorts of latencies we're trying to reach, Hashgraph can run at transactions per second, consensus transactions per second, up to 500,000 transactions per second, and that's in a single shard. So sharded architecture, we're going to probably get some magnifying effect. So performance is perhaps the most notable differentiator relative to other public ledgers, blockchains in particular. But there are qualitative and not just quantitative differences between Hashgraph and blockchain. One of which is the nature of the consensus that we can deliver. Hashgraph is asynchronous VFT, asynchronous Byzantine fault tolerant, which in this context really just means that when we work out the consensus timestamp for a given block of transactions, we don't do so in any sort of probabilistic, I'm feeling more and more confident, I'll think I just wait for one more block confirmation, as in the public blockchains. We have finality of consensus. When consensus is reached, everybody knows it, and they mathematically have finality in the certainty that consensus won't change. We're not going to change the answer based on something that might happen down the road. So a very different sort of consensus, and one that makes Hashgraph, we think, relevant to lots of business transactions that require that sort of finality. Another aspect is what we call fairness. Blockchains, by their nature, typically empower a particular actor, whether they're called miners or stakers or delegates, for a given period of time to be the one that decrees what the latest block of transactions being added to consensus are. Now, how that actor is chosen, whether it's by competing a proof of work puzzle, or based on how many coins they have in a proof of stake model, or based on their reputation to some extent in a DPoS model, all of those ultimately at the end empower a single node to decide what consensus is. And so even for a very short period of time, that miner, or whatever we call it, has the ability to decide which transactions get added to the block and which don't. And so there's the opportunity, at least, for that miner to abuse that power. And for instance, to only add transactions with the highest fees, or not add any transactions at all from a particular client, if they chose to abuse that power. So we would decide, or we would describe that model as unfair in the sense of showing bias towards given clients or different actors on the network. And Hashgraph doesn't do that. We do consensus differently, so we don't have that specialized node even for a short period of time.
Great. Definitely thanks for that explanation. And also, I guess now, do you currently have a minimum viable product, or MVP? And maybe when can we expect your MVP to be fully functional?
Well, as I said, there's an SDK now that is optimized for the permission deployments of Hashgraph, and so that's been available for over a year now, and customers have downloaded that, built POCs on that, and as I said, are starting to roll out production deployments. So on the permission side, we have arguably more than an MVP. We've got that working SDK. On the permissionless side, on the public ledger side, we will be rolling out comparable functionality to the SDK with an architecture more suited to the public side and wallet apps and comparable. And we'll do that over 2018. So we'll roll out the services associated with the platform. We'll roll out the mainnet running the consensus algorithm, and necessarily do at the same time distribute the coins to the community and to the developers that ultimately will drive the economics of the platform.
That sounds great. And also now, I guess, what is the utility of your token?
For any public ledger, if you want to inhibit certain attacks, like a Sybil attack where an attacker can spin up or create millions of malicious nodes and thereby skew or prevent consensus, we need to mitigate that risk, or to make that attack significantly more expensive, by requiring that nodes demonstrate that they have some scarce resource. So in Bitcoin, that scarce resource is CPU or GPU or ASIC, computing power. In a proof of stake model, the scarce resource are the coins associated with the platform. So for our Hedera platform, there will be a native currency, and that token will be used in a number of different ways. First and foremost, we'll use it to weight the votes of the nodes participating in consensus towards establishing the consensus. So Hashgraph, the algorithm, has what we call virtual voting. It's a way by which the nodes in the network, those that are contributing towards consensus, are able to collectively vote on what timestamp should be assigned a given block of transactions, but critically do so without actually casting ballots and sending them over the network. So it's a virtual vote where every node effectively looks at their own local copy of the history of transactions, the Hashgraph, and votes, in a sense, on what they think the timestamp should be for a given event within the Hashgraph. Now, in a permission deployment of Hashgraph, that voting model is very simple. Every node gets one vote. So it's easy enough to count up the votes and thereby calculate consensus. Now, in a permissionless or public deployment of Hashgraph, as I said, we've got to mitigate civil attacks. So we require that every node contributing towards consensus stake a certain amount of coins or make a stake of coins towards consensus. The logic being that if an attacker has, let's say, 100 coins, and they divide those coins up amongst 100 Sybil sock puppet nodes, then they haven't gained anything because their net influence remains the same. They still have 100 coins, it's just distributed amongst 100 nodes. So that's, first and foremost, we use coins to weight consensus in a staking model, as many other public ledgers are moving towards, right? Casper and the DPoS. They do stake in a different way, but the fundamental premise is the amount of coins a node has determines to some extent their influence on consensus. And we use that same model, but in a different way. Right. Secondly, also fundamental, is we want to compensate nodes who are spending real money on bandwidth and CPU and storage in order to participate in defining the consensus for the transactions that are flowing into the network. Those are real costs, and so we want to compensate them. And more than just compensate them, we want to reward them. We want to make it profitable to be a node in this Hedera network. And so we will pay them. We'll pay them a reward that is proportional to how much stake they've contributed towards consensus. Because ultimately we want to encourage all nodes to put that stake towards consensus, because that improves the security. Now, if we want to reward nodes for participating in consensus, somehow we have to fund those rewards. And that's the third use of the currency. We will charge clients of the network, those who want transactions entered into the ledger and recorded into consensus, we'll charge them fees. They'll be very small relative to current Bitcoin and Ethereum fees, because the efficiency and throughput of Hashgraph relative to blockchain, but they'll be significant enough to, in the aggregate, pay those necessary payments to the nodes, inhibit spam from the clients, because sending out millions of fake transactions isn't viable if you're being charged a fee for each of those transactions. And so the token ultimately has multiple utility and function within the platform.
And I guess also, would there be any changes coming up in the code or on the network for which your token is built on, or Hashgraph in general?
I think I touched on some of them, right? One of which is the necessity of some sort of staking model for a public ledger. So we'll do that.
Okay.
Fees clearly are an aspect that are not required on a permission network where all the nodes know each other, and there's sort of an inherent reward just for participating in the network, because you get to have access to the business transactions that are relevant to you. A future enhancement to the network, one that will evolve into, is sharding. Sharding will ensure that a given node, once we evolve to the point where it's relevant, a given node doesn't have to participate or contribute towards consensus of every transaction. Instead, we actually divide the network up into subsets of nodes. Each subset or shard of the full network only participates in consensus for a subset of the transactions. So we expect that we can maintain the sorts of high performance TPS that I talked about earlier, even when we start hopefully to get to the sorts of millions of nodes that we would deem as a successful network. So shards are another enhancement to the architecture that are probably required for a public deployment of Hashgraph, but we don't think we'll need that right away, just because we won't, at least initially, have that many nodes. We'll roll out Hedera in a controlled manner. So by design, we won't have as many nodes as would make sharding relevant in the early days.
Great. Interesting. And I guess, could you maybe also shed some light on the developers of the Hashgraph or Swirlds team?
Yeah. So we're building that out. Swirlds, every day I see some new dev being hired by Swirlds to help build out that team, but we've got a strong community, both internal developers and external developers active on Discord. Yeah, and their work is somewhat distributed and divided amongst continuing to enhance the Swirlds platform that I've described, while also building out the public ledger architecture more relevant to Hedera. So, Hashgraph is the common base layer, but building out suitable architectures appropriate to the different use cases for both permissioned and permissionless.
Great, great. And maybe has any of your team members or advisors has had any successes that you wanted to highlight or mention?
Mance and Lehman, the co-founders of Swirlds, this is probably their third or fourth company that they've launched together, and
Great.
they've had successful exits. Some of their ventures were identity management centric, that sort of thing.
Interesting. Cool. Awesome. And here's the next question. Can you create an ERC20 token on Hashgraph?
So on Hedera, the public platform based on Hashgraph, yes. Okay. So the first release of Hedera will support Solidity smart contract scripts, and we've been testing out that functionality, effectively allowing any existing Solidity script, ERC20 amongst others, to run on Hadera as if they were running on Ethereum or another ERC20 compatible platform. Great.
That's pretty exciting. And
yeah. I think it's an encouraging sign of interoperability across platforms, right? A small example of some level of interoperability. And it's not just Hadera and Ethereum, the other emerging blockchain-based platforms seem to be doing the same.
Great. And can you maybe describe a little bit about transaction fees on the Hashgraph network?
Sure. Yeah. So we have a, as I said, a fee model that logically is designed to reward, at the end of the day, reward nodes for doing the work of establishing consensus. Now, the structure or the different fees recognize that different nodes take on different burdens for the processing and establishing consensus for a given transaction. The first node that hears about a transaction, so if I've got a wallet app on my phone, I'm not a node in the sense that I'm not directly contributing towards consensus. Instead, I'm going to send that transaction to a node and effectively ask that node to on my behalf, send that transaction into the ledger or into consensus. So that first node has costs almost independent of running the consensus algorithm. It's got to support an API by which clients like my wallet app can post transactions into the ledger, and by which the wallet app can subsequently request to read from the ledger, get a balance update, etc. So that's one fee. That we call a node fee, to compensate the node for supporting the costs of acting as that proxy for non-node clients. Separate from that, there are other nodes in the network who didn't receive that initial transaction request, but nevertheless have costs associated with supporting that transaction. Specifically, they've got bandwidth, and processing costs associated with establishing consensus timestamp for that transaction. Now, all nodes have that same cost, even the one that first heard of the transaction and submitted it out the first time. So all nodes will receive a separate transaction fee that is distinct and separate from the node fee I described earlier. And thirdly, we also want to recognize that depending on the nature of the transaction, a node might have a longer term commitment or burden associated with a particular transaction. If the transaction is merely me sending you 5 coins, then there's no great long-term storage burden to that transaction. But if the transaction is me storing a file on the ledger, a multi-gigabit file, then nodes participating in consensus will have a significantly greater storage burden in supporting that transaction. So we acknowledge that with a third fee called a service fee that recognizes that this sort of rent is necessary to appropriately compensate nodes for that longer term commitment towards a transaction. I see the Ethereum community recognizing the need for that sort of rent fee and to acknowledge the costs of an Ethereum miner or node maintaining a smart contract and running a smart contract.
Great. And also now, I guess, what is the name of Hashgraph's token?
So I don't think we have an official name. We have a number of competing internal names that we somewhat use interchangeably.
Cool.
I think I'll hold off on on what is the leading contender for the ultimate name of the coin.
Gotcha. No problem. And I guess now also to ask you, where do you see Hashgraph by the end of the year, or Hedera Hashgraph and Swirlds for that matter? Maybe number of users, number of dApps being built on the actual platform or network?
Yeah. So Hadera, I would expect that by the end of the year, we would have our initial set of nodes active on the production mainnet. We're building out the testnet now, but by the end of the year, we'll have had the mainnet up and running and hopefully have all the initial set of nodes participating in consensus. And necessarily, we'll have a number of apps who have gone live on top of that platform. We've already had 5 or 6 public announcements of apps announcing their intention to launch on Hadera. So I think once we have a mainnet up and running, we'll quickly see we'll quickly see all those initial apps and many others following. Users, well, ultimately it depends on the success of the apps that build on us, right? We're plumbing, proudly so.
Great.
So we'll rely on the apps and their ability to attract users. Now, what we're confident of, and I think why the apps have chosen to build on us, is that we're fast plumbing and secure plumbing, and that ultimately that's going to attract a user base for no other reason than fast confirmation of a cryptocurrency purchase, seconds versus an hour, with much lower fees, like the advantages I talked about earlier.
Right. No, that's great. And also now, what is the best way to get in touch with the Hedera or Hashgraph team in case people have any more questions, even after going through most of the information online?
HederaHashgraph.com has white papers and links to various videos. Depends on how deep your audience wants to go in understanding Hashgraph. We have an active Telegram group, an active Discord channel, more focused on dev and technical questions. Lots of different channels by which people can learn more about Hashgraph and Hedera on top.
Fantastic. Well, definitely thanks for taking the time to join us today, Paul. I really appreciate all the information. I'm sure a lot of our audience, finds tremendous value. Will be continuously educating themselves on Hashgraph or Hedera and Swirlds as a whole. And perhaps even, I'm really looking forward to everything that's going to be developed using Hashgraph. I think you have a great team, a great project, a great community, and thank you and your team for everything that you're happening to do and all the value that you're adding to the global crypto community in general.
Thanks very much, Tam. Nice to hear. And I appreciate the invite to talk today and your interest in general.
Sounds great. Sounds great. Well, thanks again, Paul. Everyone, you can definitely go and check out HederaHashgraph.com, join their Telegram and their Discord. There's lots of valuable information inside. And thanks again.
Bye all.